Welcome everybody, it's nice to see all of you, some new faces, some old, very old faces. No, I'm joking. Thanks a lot for joining in this summer event of Flutter Estonia. I think it's our 8th event actually.
Yeah.
So
exactly.
more than 2 years. He was there the first time, I remember. Who was there the first time?
Me.
Okay, only you too. That's cool. You didn't come. Okay,
Yeah.
got it. So yeah, thanks a lot for joining. I'm Stefano, she is Ilke. Together we organize these meetups. We meet every 3 months at least. And what we do is we bring people together under the same roof. We share some interesting talks, we share ideas, and most importantly, we have fun and we get to know each other. That's it. Thanks to Workland, amazing workspace. They're hosting us for free. So we are very happy about that. I actually work here, so if you want to try out the co-working space, you can have a free trial for 1 day. Just get in touch with me. And thanks to Code Magic, who is not here today. So yeah, we have to do something about it. We have to call them.
Yeah.
But they also...
Our hearts.
Yes. They always come, but not today. So yeah, they also sponsor us the beverages and the pizzas, Italian pizzas, we're gonna have later. And it's amazing CI/CD. If you didn't try it out. I think it's free up to a certain limit, and then it's paid,
Yeah.
if I'm not mistaken. But we also get some discounts. So if you are interested in getting more details about that, let us know. With that, I leave the stage to Ilke that prepared something. I don't know what is it, so let's see.
Oh, no, it's just like one-page presentation. Okay. I'm originally native iOS developer, but I'm so happy today because I'm finally joining as a Flutter developer today because I've been working for the last 5 months for my first official Flutter projects. So much fun, but I cannot mention the client name yet because it's not publicly announced. But before that, I have one fun fact to share with you all. So here's my question to you all. What's the highest number of PR comments you have ever seen?
Maybe 50?
Oh,
50, okay.
okay. Anyone else?
200.
200, yeah, me too.
What?
Where?
Wow, okay.
Was that a bot or something?
It's like maybe operating systems, right? Okay. Okay, I will share mine. It's over 120 for my first PR for this Flutter project, and thanks to this man, he's a really great mentor. But I was like super thankful for him. It's like because it was my first feature task, and I guess it took like 3 weeks to merge it. But I just want to say that now I can feel your pain. I have more clarity. So that's it from my side. We can leave it to Roman.
Applause for Ilke. First Flutter PR, amazing. But now we have Roman, who is also a long-time member of the community. We can say that.
Sorry.
Yeah. Yeah. And today he's going to speak about very interesting things. So I will just give you the stage and show us the magic.
So yeah, I'll start. So hello again. My name is Roman, and I've been developing Flutter apps for the last 5 years. And I've seen a lot of problems with the apps, especially when it comes to scrolling, showing text, showing images, and I'd say these are the staples of any app. And user wants to see everything smooth, everything be in their place, and nothing should flicker, all the text should fit, or at least look as it's designed like that. So yeah. For this talk, I've prepared a small project with a lot of mistakes, and I'm going to fix them on the go. And I suggest that people from the back rows would go closer, because I'll be showing some code. And let's go. So the first part would be about ListViews. So this is how a healthy list should look like. We have our area where we show children, and we have some lazy loading mechanism so that we won't initialize or render anything that is below. We only have some items that we actually need. And so the healthy list should be as smooth as possible and use only the resources it actually needs. And it should also respond to user gestures. I'll talk about that later. So this is an example of a healthy list again. And with this red dashed container, I'm showing the viewport. So the viewport is the area where the list is rendered, where a user can interact with items, and etc. And this area is called cache extent area. By default, it's about 200 pixels in height, I think. And it's like additional area where items should be initialized and built. So if we are scrolling, we have this viewport, and we have a little bit more extra so that items that are like quickly accessible would be already instantiated, built, painted, whatever, so that there won't be any junk when user starts to scroll. So that's the healthy list. And now let's go to mistakes. For example, this one, I see it very often, even not in Flutter apps, in any apps, that the viewport is smaller because people wanted to add some padding, like here or here. I don't know. I hope you can see it, but the viewport is smaller, and what happens here? The content is cropped, and the user interaction area is smaller. So if user would tap his finger here, do some gestures here, it won't react, and the user would be frustrated. So let's start. So this is my simple project, and I will show this problem here. Yep. So, sorry. As you can see, the content of the list is cropped. I don't know if you can see. Is contrast ratio enough? And, yep. So the problem here is obvious. We just have wrapped our list view in a padding widget. So our viewport is limited. Let's first see what's going on here. Second. So this is our list view. And as you can see, its viewport is cropped by the padding we were using before. So the solution is simple here. We just pass the same padding value to the list view builder constructor instead of using the widget. So this is pretty simple. All right, restart. Sec. Yep. I'll zoom in. So as you can see, there is no cropping anymore. And also, I wanted to fix this as well. As you can see, the ripple effect is drawn behind the card. And somehow this is quite often that people do that, and they just ignore it as if it's something minor. But I don't know about you, but when I use apps, I notice every little detail, and I'm super annoyed when the effects are broken, when the animations are not working the way they are expected to work, etc. And yep, let's fix this one too. So that's our list item, list style. No, sorry. Yep. Yep, this is our list item. And here the problem is that we have a card which is wrapped in inkwell, which at first sight sounds good, like what might be the problem. But the thing is, the card, the standard material card, has a material widget inside. I'll quickly go to build method. Yep. And as you can see here, we have a material widget. So what is a material widget? It's like a physical model simulation for these material cards. It can have shadows, it can have touch effects, whatever, elevation. So the thing is, if we wrap material inside an inkwell, the effect would be drawn behind the card because it looks down the widget tree, the card. It checks the children, goes inside, checks if there is a gesture detector, inkwell, and then draws the inkwell over that card. So the fix is super simple. We just remove this inkwell and place it here. Yep. It's not gonna fully work now. I'm gonna zoom in. You can see the card is. What happened? What? Mm-hmm. Ah. So yeah, I was talking about this card being rounded, but when we click, we see that the effect shape is different. So the fix is quick as well. We just add border radius to this inkwell. And second. Why is this part important? Why I'm talking about this? Because sometimes people see that the ripple effect is not matching the shape, and they just wrap this into a clip rect or clip R rect and pass border radius, which is not correct. You are using excess resources for that. Inkwell already has border radius, and by using clipping, you are using offset buffers, I think, and it's like excess rendering calculations, which could be easily avoided. So yeah, let's go back to our slides. So that's the next problem, also very common. As you can see, we have a list with 3 items, and the problem is that the list calculates its size based on the on its children. So what's the problem here? The problem is the gesture detection area is cropped to this red area, and if user would scroll here, there will be no reaction. Second, if we depend on our children to calculate the size of the list view, then we are not able to leverage any lazy loading because we have to calculate all the children's sizes before we can show the list. And we'll get back to it. And here is another example, also with the same problem. We have our list, and it's wrapped into another scrollable. And here we have some footers, some headers, and the list is inside of this. I think it's a very common thing to implement in mobile apps. And the problem here is that sometimes lazy loading is not working because of the same problem. And let's just open the code and see what we can do. So that's my example. This is a scaffold with a single child scroll view, and inside we have a column, and then we have a header. This is our header, then a list view with a builder. Like they say, use list view builder, it optimizes your app, whatever. But the thing is, if you set shrink wrap to true, none of the optimizations is gonna work. And you are wrapping a scrollable inside of another scrollable, which is usually not the way it should be done. And yep, so there is another problem here. Okay, so this is iOS. And then on iOS, we are used to scrollables to be always scrollable, not like on Android, where if the list is over, then we don't over scroll it, we rather show some effects. And here we don't actually, we are not possible to do it, but let's try some broken approaches, I'd say. What if I set the physics of this root single child scroll view to always scrollable? Should work. Yeah, it works to some extent, but it works the way that it clips because the viewport is small, limited. What if we, I don't know, clip behavior set to none? Then it won't clip anything. So, perfect. We just disguised our bug, because if user would like to scroll from here, it won't work. So there are two ways to make this layout. Well, there are many ways, but I'll talk about two ways. One is simple, another one is a bit more complex, but there is more possibilities. So I will move this a bit. And I will just use the regular list view. And I'll just pass whatever I have here to the list view. So the header, the footer, and these list items. I'll just use a loop to draw them. And I remove this completely.
How did you remove it in one click?
You mean this?
Yeah.
I've put the selection like that. Yeah. Why my cursor autocomplete is not working right now?
Yeah, that's a good question.
Okay, whatever. So yeah, now we have a list view with all the things inside. We have header, we have this for loop with items, and we have a footer, and it all works. And what happens if there would be 1,000 items? It is still smooth. If we look into the widget inspector, like this, there is item 44. I'll try to zoom it in a bit. Yep. So, as you can see, there is item 50. And then it ends at, it starts with item 39 and then ends with 51, which is totally fine because we don't see the first item here in this screen right now. We only see these items. And as I mentioned before, it renders a bit more because of the cache extent area. So we have 52, item 52, the last one, but here it's only 49. So yeah, but we don't have thousands of items here. If we compare that to the initial version, where we would put, where we would put 1,000 items. There is. Come on.
I guess you can do a git rollback over there as well.
Yeah, yeah.
Cursor knows that you're doing a demo.
Never trust cursor. So yeah, going back to that example. Yeah, good luck trying to scroll this. It can happen, for example, if you are working on a chat feature and you test it, everything works fine, but then the real users come and then they have a long chat history, and then this happens. I think Facebook Messenger app still has this problem, but I'm not sure. But at some moment they did. Yeah, and I want to show what happens in the widget inspector. So there is this item 30, then we scroll down, and we have everything. That's not the way to go. So yeah, let's keep it as is. I've shown what I want to show on this screen. There is a more difficult way to do the same. I'll start with creating a custom scroll view. So the list view and custom scroll view are basically, they use the same mechanism under the hood, but custom scroll view takes slivers as children instead of regular children. So the difference is regular widgets have their render objects as render boxes. So render box has like position and size of rectangular or square size shape, while sliver render, I think it's named sliver render, yep. It has, besides that, it has a scroll position. So we can do some parallax effect, some collapse in up bars, whatever. And we can make a sliver list here. And it would be basically the same item builder we had before. Here I will return the same list item. The thing is, we cannot pass our header widgets directly to the slivers because we expect children to be having sliver render objects, and this one won't work. But there is a simple solution for that. We just wrap our box widget into a specific adapter, sliver to box adapter, and I'll do the same for the footer. Here the paddings are missing, but I'll get back to them. Where's my simulator? So yeah, this is our updated app with custom scroll view. Looks more or less the same, but the paddings are missing, and here we don't have a paddings argument. Instead, we have to wrap it into sliver padding and then send the desired values. And it's not a child, it's sliver. So we have achieved, basically, we have achieved the same layout, but with a bit more code. Why does it matter? Because we have a slightly more optimized mechanism here. We don't have to... Okay, forget what I said. I'm not gonna go that rabbit hole. Let's go to another example.
But so in this example, is there any benefit over using the...
I'd say mostly in this case we are using sliver list builder, and if we have thousands of items, in the previous example where we were using the 4 for loop, we were creating all the widgets. So we were creating the objects that would be used later by elements, by render objects, but the widgets themselves are initialized. So it might take some microseconds, so the optimization is not very noticeable here, but this is slightly more optimal.
So sliver list is more performant?
Sliver list with builder, yep.
But it doesn't build all the items at one time, right?
No,
It just does what you need in the viewport.
only
So
what you need,
1,000
yes,
items, it
yes.
does like 10 or 20 at a time.
Yes, and when you are using the regular list view with 1,000 items, they will initialize, but they won't go through layout phases and rendering. They will just initialize their configuration. Alternatively, you can use list view with builder, but then you won't be able to easily add headers and footers.
What if we want the header and footer to be persistent?
Then we can, for example, this could be a column. And then we have our list view here. And it will have some children, and here we would have a footer or a header. Here we'll have a footer. So what happens here? We draw a header, we draw a footer, and then the remaining space would be distributed to the list view. So the viewport would be of size of remaining space after header and footer were laid out. And yep.
So in this case, all the children won't be when in the
Yes, yes. We will still have lazy loading here. If that's sticky header and footer. And in slivers, there is some custom behavior, sticky footers, and a lot of libraries too. So if we are using it with custom scroll view, we have more control over that. So I'll revert it. Because there is this difficulty because I'm using increased scale, and some of my UI elements are overlapped. But whatever. I think I can go next to images. Yep. So here we see an example of healthy images. They are shown fast. They are using cache. If we download image from network, it is cached in our cache storage. And if we have shown an image in the user session, then we store the bitmap in the memory cache. That's two different types of caches, and people sometimes forget about that. So, this is image cache. Flutter has a specific storage for bitmaps. So when we are downloading an image from internet and we want to show it, we cannot directly show JPEGs or PNGs, whatever. We only work with bitmaps, BMPs, because this is basically how computers show images. It's a matrix where each point in the matrix is a pixel. What's this? Thanks. So yeah, in this example, the image of the bitmap is the same as shown on the screen. And sometimes people forget about that and they just ignore memory cache. And by default, if we have this grid of images that are used from assets or downloaded from the internet, they will be decoded in the original size. And for example, this image is like 5 times bigger than the siblings, and it takes a lot of place in the image cache. And by default, in Flutter, the cache is limited by 100 megabytes. Yes, you can extend this, but it's not always a good practice to give more RAM when you can optimize. So yeah. Let's go into the code. I think I'm going to use Android here because it supports profiling. No. And while it's compiling, I would tell something more here. So yeah, this issue might come from different sources. For example, you have bundled your app with some image, with some background photos, and you just use the original size. Let it be, I don't know, 20 megapixels taken from camera, and you are using it here, but the bitmap size is too large, and it can even ignore the image cache if it's too big. If the bitmap is larger than 100 megabytes, it won't be able to be stored in the cache, and it will be re-rendered every time you open the page or you scroll to the list item that contains that picture. So I wanted to show you profiling view, where you can see second, memory. Yep. I'm waiting for assemble profile to finish the task.
Do you know if image cache also works the same way in a web build, or they delegate it?
No, I don't think it works the same way. I think it utilizes something in the browser engine. I don't know. But on mobile, yes, on Android and iOS, it uses this memory cache. Yep. So in VS Code and Cursor, you can actually have this Flutter sidebar. It has a lot of useful things. I didn't know it existed before. I have randomly found it out. And if you are using some libraries like shared preferences, provider, it will also show their plugins here, which is very useful when you have to debug something with preferences. And where is my build? Okay, let's wait a bit. And I can actually show the code. Meanwhile, it's loading. So we have an image asset here, which just uses some picture in the assets. And as you can see, that's an image we are taking from the assets. And here, I'll pause it. This is the memory chart. As you can see, the memory consumption was quite modest, like 300 megabytes for Flutter apps is okay. And then when we opened the page containing the picture, the memory consumption rose up to, I think it's 550 megabytes. So that was the moment when the image rendering engine was creating bitmap. Then, after it was rendered and shown on the screen, the memory consumption has increased from the initial point by, I think, 80 megabytes, which is quite a lot for a single image. So what we can... I wanted to show one more thing here. I go back, I open it again. You see the flickering. The image was already loaded from assets, it was already decoded, but it was too big to fit in the cache. So it is rendered again. Of course, the easy fix would be to use a smaller asset. Like I have a smaller image here. That's the big one. It's 5 megabytes JPEG. I can use a small one. Okay. Of course, I can do it, but then we'll have to wait for the profile build to finish. I'll show the solution at once. So our image assets have this cache height and cache width parameters, which are often overlooked by developers, but they're quite important. This tells the size at which we are decoding our image to bitmap. Maybe I was not totally technically accurate in my wordings, but I guess you are getting what I'm saying. And we can't just send their random size or just send like 100 because the image then would be blurry. So what we are going to do, we are going to take the width of we're going to take the width of our screen, like we go to media context, media query, take the size of the screen, like the logical size, and then we multiply it by the pixel density. So this might be like 300 pixels in logical terms, but in physical terms, it's like 1,000 pixels, maybe. So I have these things ready. So we get width like that, media query, size of. Why don't we use this? It looks like it's the same, but the thing is, if we do it like that, the build context, aka the element of this widget, would be dependent on all the changes in the media query. It has a lot of different aspects. It's an inherited model which has different aspects, and we are able to make a dependency between our widget's element and that inherited model, like granularly, to make it dependent only on the things we actually need. So by using size of, we are making it dependent only on the size. And another one is device pixel ratio. So we are just multiplying it here and passing this cache width here. And I guess it's type mismatch to int. Now, of course, bitmap couldn't be a double or any other non-integer value because this is the amount of pixels in memory. And having cache width would be enough here because we are able to calculate height based on that. I will restart it. And yep, here this is how we are accessing the image cache. We have a painting binding, and we can access it everywhere in the Flutter app. We don't have to know anything about the context. We just go to binding, go to image cache, and see what's inside there. Okay. My macOS is a bit weird. Somehow this dock never disappears. If I am in a full screen, if I'm not in a full screen, sometimes it just disappears, sometimes it's there and cannot go away. So as you can see, the image appeared without delay. There is no flickering, there is no weird spikes on the memory chart. Works as designed. And I can stop it, I think. Yeah, so here we can check the image cache, and we can actually go inside and see what's there. So there is a map of pending images. So if we are putting anything into the cache, it will first go to pending images, and we are able to actually check what's going on. There is a lot of different properties here, and we can adjust it by this one is setting the size. For example, we can increase it twice. If we are working on a photo editor app, then we might actually increase the painting binding image cache size, but other than that, I wouldn't recommend wasting users' memory on that. Okay. I think I have shown what I wanted to show with this.
What would be the case where we have to use the gas height as well?
For example, if you want to make a different like fit, if you want to use boxFit.cover, then you are okay with using just width, but sometimes you need to make it like fit height or to fill. Then you would use height or both. But usually width is enough, and width is easier to calculate. In most cases, it's either some avatar, like 40 by 40, or full width image. Okay, so what's next? This is another example, and here we are talking about layers. In Flutter, the process of rendering works that way, that we first build widgets, then we calculate the layout for the widgets, then we paint them, and then we are compositing this like painted rasters into a GPU-friendly format where the layers are isolated and calculated more or less independently, and then we merge all these layers into a frame. So what's here? What's wrong? We have 3 images, and every single image is using a separate layer, which is not optimal. We are doing a lot of excess calculations here. Here we can use just one layer to draw all these images. And this happens if you are using opacity widget, for example, if you are using image filtered, color filtered, and not to mention the backdrop filter, it will have even more serious impact on the layer tree. But without further ado, let's show, I think that, yeah. So what we have here, we have a small list with items that have an image, and we want to have this image like half transparent, and we are just wrapping our images into opacity widgets and passing like 50%. So how does it work in Flutter? By wrapping this into opacity, we're telling the framework, like, look, take all the children. It could be a difficult widget tree, anything. Move it to a separate layer, then render it, then take the render result and apply a 50% opacity filter on it. And that's a bit of an overkill. Let's open there. Okay, so here you see these images. I think half a year ago, the Flutter team has removed DevTools utility that allowed to show the layers. Now it's gone, but we can output that in a console. But before, there was a visual tool that allowed us to watch layers. But they have removed it because of the impeller, because nobody was using that feature and it was too hard to make it work with the impeller engine. So yeah, now it's not available. But yeah, I wanted to show the layer tree.
They probably want you to use imagination more.
Yes. So let's take this 5th children, and I'll try to explain what's going on here. So that's one of the cards shown on the screen. We have an offset layer, which means that we move our image to some extent. So here we have x equal to 0, and then we move it on the y-axis. Then we have picture layer, that we have the bitmap and show it. And then we have an opacity layer. Then we have another picture layer and another, because this is a complex calculation. We can avoid
Is it
that.
just for one image or for?
For one image, for one card, yeah.
So like 4 layers for one?
Yes. This could be easily avoided, because what actually opacity is, we are taking the rastered image and then we apply a color filter on that. We take white color. We can color. Let me quickly write it and then explain. White with values. So yeah, in Flutter it is possible to ignore all these steps and apply the opacity during the rendering of the image itself. So here we are passing a color to the image. We just take white color with 50% alpha channel, and we use color blend mode of modulate. There are many color blend modes, and if you were working with any graphic tools like Photoshop, Figma, you might be familiar with what that means. But yeah, okay, let's not go there. Yep. So here we have the same layout, it works. And if we check the layers, so this is child 4. We have offset layer and we have a picture layer. Only 2 layers were needed to show the card. It's way more optimized, but usually when it's a simple app, you don't notice these things, and when you're debugging on your device, it's fine. But when it comes to real users with cheap phones in some weird conditions, then all these problems start to bleed the performance out of the device, and the app is lagging and users are uninstalling the app. And yes. Okay. Okay, let's go to.
Can I ask a question?
Sure.
So how to think about the optimizing for minimizing amount of layers? Is it only filters and opacity, like type widgets problem, or?
It is mostly misuse of opacity widget, of color filtered, of image filtered. I cannot direct.
Basically anything that can capture widgets underneath.
Yes, sort of.
So everything?
No.
Like any type of widget that needs to like capture what's below it.
Even clipping needs it. If not all clipping, but if you wrap it into.
But you say that opacity is the main
Yes.
culprit.
Yes. If you do, if you set clip behavior to anti-alias with safe layer, then it works the same way. It creates a new layer, as is said there.
Did the screen freeze?
Yeah.
Screen freeze.
No, it's just full screen.
Ah, yeah. Sorry.
Full screen mode. Yeah.
But I was not showing anything too important. Just if you use clipping with a specific anti-alias setting, then it will create a new layer too. Yep, so let's go to the text section. So this is an example of a healthy text. We have our title, it's on its place, it has some rich colors, rich text settings with colors, and everything fits, everything is readable. And here we see one of the most common issues, that the text is not fitting into the box. It was it was thinking that actually it has room to draw it like that, but reality was different. Then I'll open the code again. Yeah, this example, like here, as you can see, it's all fine. We've developed our app, we've tested on our data, it's all fine. Then the real data comes and nothing fits. So there is many ways to tackle this problem. For example, you can add an ellipsis. Here it would show 3 dots if it doesn't fit. Like you can set maximum lines. You can set here expanded. You can wrap this into an expanded widget so that it will take as much space as it needs. And I will quickly fix these issues too. So for example, here, this column could be expanded, for example. Let's see if it helps. Yeah, so by using expanded widget, we are telling that this column with these texts should take as much room it needs in the context of this column or row. And here we have another problem. We have our text cut off. Here we can just use list view instead of we're using a list view here instead of a column because the actual size of the screen and the actual size of text might be different from the test values, and we should always take into account the possibility for the text to change their sizes. So that's the fix. Now it scrolls, now it fits. I'm not going to go deep into how this could be customized. I think I have a couple of more examples there. Oh, yeah. So imagine we have to implement this screen. For example, we have no data, please try again, texts there, and it all works. We made 2 text widgets and put them into a column, set cross-axis alignment of that column to a center, and it works fine. But then another subtitle comes and it looks like that. What happened? We had our alignment in the column set to center and we still have it centered, but the text itself is aligned to left. So we have to pass text alignment property to the text widget itself to make it look better. Center text. So yeah, this is how it looks. If we extend this text to be longer, for example, another localization, we'll see that it's not aligned properly. So what we are going to do, the fix is super simple. Text align, center. Done. Now we have it fixed, as the text is aligned inside the text container. That's another issue. We wanted to have our title colored with these rich text settings, and for some reason the font is default. Like we are using robot as default text in the app, and now we see that our title looks different from other texts. That's happening because the default constructor of rich text in Flutter, the default setting is to ignore the text styles that are already in the context of that widget. Let me show what I mean. Okay, so here we have some texts, and we have a rich text with 2 colors. And if you look closely, that's a different font, and it ignores the color settings too. And if we change our theme to light, then we can see that nothing has changed. It should have become black, but it's white as it was before. And the fix is simple here. Instead of rich text, just use text.rich. And I think you don't need this. Let's see. Right, now we have the font that we were using throughout the app. And if I change the theme, then it works fine. Yep.
This begs the question, what are the use cases for the rich text widget?
When you want to ignore the text settings completely, like it could be really hard to trace what text settings you have if the ARP is large and it has a lot of themes, and rich text would just reset them.
So pessimists and optimists.
So yeah, that was the same example. And another problem is having a poor contrast. For example, you develop an app, you make your designs yourselves, and then you look at your app, it looks fine, you distribute the app, and then users are deleting it. What might have happened? You developed it in Estonia on your MacBook with window blinders, and somebody in India has installed your app in some Indian phone, and they have sun, they have a lot of brightness, and what happens is unreadable text. It's easy to fix too. Here I have some colors, and there is a lot of tools available. You just Google for contrast ratio checker, and just open the first link here, and you send your values. You check your values here. So the contrast ratio is 4. It fails a lot of tests. So what you can do here is to adjust the colors so that the contrast ratio would be at least 8. It goes this way. No, sorry. Yeah. It still fails the test. But by changing the lightness, I'm still having the same like tint of the color, but I'm just increasing the contrast. So these colors would have the same vibe, but the contrast ratio would be better. So that was the poor contrast screen. And then we apply changes, and now it's more contrast. And that's it. Thank you for your attention. It's time to ask your questions, and I have all these materials in format of articles, which could be accessed by this QR code, and I have Medium blog and Twitter, which is there. So yeah, hope you learned something new.